Welcome to Building iOS Apps in SwiftUI. Today we're learning the Swift programming language. The Swift programming language is used in SwiftUI. That's not very surprising, is it? We'll be learning programming basics on things like variables, constants, types, operators, and printing. And we'll use these concepts to build a fairly useless app, but maybe you can come up with some concept for it that makes it actually useful. We'll see. Let's get started. Let's get started by taking a look at this example app that my colleague Jia Chen has prepared for us. It's supposed to demonstrate a few concepts like functions, variables, operators, and conditionals. So just taking a look at this code seems fine. Let's take a look. We need to press run my code. And he did tell us, it's Rick again. All right, anyway, so he did tell us to do a bit of optimization. We have to turn off this thing over here. There's this enable results. And now we can run the actual app. Oh, I gotta run my code first. Let's run my code first and then raise the flag. Okay, so it's a simple little app where you hoist the Jolly Roger, and since you can't bring down the flag, he's never gonna let you down. That is fantastic. Right, thank you very much to Jia Chen for this thing right here. In order to make this, we are going to have to learn about various things. There are variables, there are constants. Actually, there's no constant in here. There's functions. Here's a function right here. And there are operators and printing and if statements and things like that. We won't actually be covering if statements and functions in this lesson, but we'll learn enough to make a counter app that is going to be the basis of this flag raising app that we will make by the next lesson. Let's get started. First, let's close this monstrosity and create a new playground. So you can just go click here, click on blank. And what we want to do from here is you actually just want to go and grab the same code that you grabbed last week. Let's head over to Safari and head over to tk.sg/swiftpg template right here. And this is a bit of code that you can just copy and paste into your Swift Playground. Okay, delete the first blank line that you get. And if you press run my code, it's going to give you the hello world over here. I'm going to turn off enable results as Jia Chen recommended. And I'm going to switch myself over to light mode, right? So wear some shades for this part because everything's going to be really bright. Okay, here you go. All right, and if I press run, and here you go. We'll come back to this playground afterwards, but for now, I'd like you to head over to the left bar and making sure that you have a left bar by clicking on this button over here, or tapping if you're on an iPad, and pressing this plus button over here to create a new playground page. Let's call this Learning Swift. And if you click on it or tap on it, you can actually type Swift code over here, and we'll bring back some of our concepts over to the playground when we're done. We'll get started by learning some Swift concepts, specifically variables, constants, and types. We're back in our playground. Let's type in some code to create variables, and I'm kind of hungry, so I'm going to say var number of Nutella jars equals to 10. Okay, and var my name equals to yj, and var am I hungry equals to true. Here's 3 variables of 3 different types. You can tell they're different types because, well, they're different colored and therefore they should be different types. That's my logic and I'm sticking by it. What if I want to change one of these variables? So I'm going to say number of Nutella jars. Notice down here that the variable name is popping up. Swift actually knows about this and is auto-completing it for me. So that's nice. I'm going to press enter and we get number of Nutella jars auto-completed. And I'm going to set it all the way down to 0 because I ate them all. And I'm going to leave a note to myself using / I ate them all. And maybe an emoji over here, right? Yum. But what if there are things I probably wouldn't want to eat? So let number of dishes equals to 5. And if I try and eat my dishes, let's see what happens when I type out this code. oh, there are red dots all over the place. This usually means something's gone wrong. So let's click on one of the red dots and it'll tell me what's wrong. And over here it says, oh, what's this? Change let to var to make it mutable. Cannot assign to value. Number of dishes is a let constant. Change let to var to make it mutable. Same suggestion. So let's take a moment to pause and talk about what we've just done. We made 3 variables, one right here, one right here, and one right here. And they all came with names. So I'm going to draw those as little luggage tags. Okay. And I'm not going to write the entire name here because my handwriting is terrible. So this is Nutella. Told you my handwriting was bad. This was my name, and this was Am I Hungry? I hope you can kind of tell from this little scribble. And each of them was a different type, right? Number of jars of Nutella started off as 10. My name was YJ, and it still is YJ. And am I hungry? True. Still true. After that, we created something else using a different word called let. And this let thing that we created, was the number of dishes. It also had a label, number of dishes. Pretend I just wrote number of dishes. But it's slightly different in that there's a bit of a, there's a lock around it that kind of prevents anyone from coming in to change it. And we wrote some code just now to actually change our number of jars of Nutella over here from 10 to 0. Each of these little boxes are variables, and variables are where you can store all kinds of things. Up here, you have an integer, int. Over here, you have what's called a string, which is a piece of text. And down here, you have something called a boolean, we call it a bool. Over on this side, this is also an int. And we're going to see these different types in action over the rest of this course. Back in Swift Playgrounds, we're going to fix this problem by, deleting this line. We now know that let essentially defines a constant, and it means that you cannot actually change something that's created by a let. You can go ahead and change anything that's created by var. And when you change something, you don't actually have to put the word var in front of it again. You're just kind of using it. The first time you do need to put var in front, that's when you're declaring a variable. And afterwards, if you're using it, you don't have to. Here's something else. I mentioned types. When we type var number of Nutella jars equals to 10, we're actually doing this. Var number of Nutella jars :int equals to 10. And that's telling Swift that I'm creating a variable called number of Nutella jars. This is the luggage tag. And inside the luggage is something called 10. And what's the type of thing in the luggage? It's an integer. Now, Swift is smart enough to actually deduce this, So you don't actually need this line over here. So you can say var number of Nutella jars equals to 10. And you'll figure out, sure, no problem. I think that's an integer. And I think this thing right here is a string, so you don't actually need to do this where you type :string. And similarly, you don't actually need to type var am I hungry as a bool. So these are all the types that we've just seen, and we're telling Swift what they are using these things called type annotations. The great thing about Swift, though, is that you don't actually need to declare these type annotations when you declare your variables. Swift kind of knows. Var am I hungry, and you use the word true. It's a special keyword, and it's either true or false. When you use these double quotes, you know that it's a piece of text, and Swift will deduce that, hey, this is a string. However, for numbers, it's a bit of a different story because numbers can be either integers or floating point numbers. And floating point numbers are just numbers with decimals behind them. So in theory, I could do this. I could say var number of Nutella jars double equals to 10. And that's a completely different type of number. Let me illustrate this with an example. I think number of Nutella jars is not a great example. Let's talk about height. So for example, there could be someone out there with a height of 2 meters. And if this person got a haircut, maybe they had, really big hair, their height could reduce to 1.95. So we could do this. Height equals to 1.95. And this would seem like a perfectly sensible thing to do. It used to be 2 and now it's 1.95, but Swift tells us no, cannot. Because you cannot assign the type of double to type int. You cannot put 1.95 into something that is actually an integer. this might be strange to you, and it's strange to people coming from some other programming languages like JavaScript and Python. And that's just the way Swift is. Swift is very, very strict about type. So right now, this is an integer because you put 2 here and Swift assumed that it's an integer. There are a couple of ways to fix this. You can put .0 over here. You can put height equals 2.0, and Swift will know that this now you actually mean a double type. Another way is you could add the type annotation. You could put var height colon double equals to 2, and now you can get away with this line of code without any errors. I'm not sure if you noticed though, but when we first tried to put double into an integer, or so Swift thought, there was a suggestion from Swift Playgrounds. So I want to take a look at that because it's actually somewhat educational. So if I click on this, it says, hey, there's a little fix button over here. It's very tempting to press this fix button and hope that all your problems are solved. Okay, so it says insert int open parenthesis, insert close parenthesis. Let's click on that, and here's something new. What Swift Playgrounds is suggesting you do is to change the type of this number right here, and you will get an integer out of whatever is given to this int function. And we'll talk about functions very soon. And what this actually does is it returns you 1. And suddenly your height has gone from 2 to 1, and your height is still an integer. So this doesn't actually solve any problems, but it becomes code that Swift Playgrounds can compile. And Swift Playgrounds is happy, but you are not. So watch out for these things. There is a chance that Swift Playgrounds will suggest some fixes that are not quite what you want. So I'm going to undo that and change it back to, have the double right here. At this point, I'd like you to try and fix some Swift code that's got some problems. So press plus on the left-hand side, type in exercise 1 variables. You can call it anything you want, but inside here, I have some code to type up. I'd like you to follow along as best you can. Var potatoes equals to 10, var temperature colon int equals to 30.5, let bananas equals to 20, let name equals to hello everyone. That's not a very good name. Bananas equals to 10, name equals to 500, and potatoes equals to 10.99. All right, this is going to give you all kinds of errors everywhere. I would like your help to try and fix this if you can. There are many, many ways to get this right, and I would love to see your answers. Please send them over to this website over here. Let's try fixing these up. So let's take a look at the errors first. The errors do give some useful information, even though the suggestions might not be what you want. At the top right, you will see all the errors, and on the left, you will actually see each individual error over here. Okay, so you can open them up and just see all their suggestions. And the first one says, cannot convert type of double to specified type int. It's a temperature reading, and we can assume that it's going to need a decimal place, so we're just going to change this to type double. And once you fix that, the error goes away. Next, it says there's an error with let bananas equals to 20. Now, there's actually nothing wrong with this line. The problem, though, is that down here, we see that we try to make bananas equals to 10. What's wrong here is that we are using the let keyword, which sets this up as a constant, and you actually want to change it afterwards. So they're suggesting change let to var to make it mutable. Sure, that's actually fine. So press fix. And now you have a variable called bananas, and you can change it to be 10 afterwards. Similarly for let name equals to hello everyone, and name equals to 500. Now this thing right here, there is actually more than one error. If you swipe across them, you can see that it says you cannot assign the value, name is a let constant, and afterwards you cannot assign value of type int to type string. So first things first, yes, let's change let to var to make it mutable. That means it can be changed. And now we're left with this error that says, hey, you can't put a 500 number into a string. The best way to fix this, if you really want 500 inside here, you could make a string called 500. Right? It's a string that happens to contain the characters 5, 0, and 0. It's not quite the same representation as 500. You cannot add 1 to this thing anymore, but it will work because now your name is 500. I recognize that these are all terrible names. And finally, potatoes equals 10.99. It says you cannot assign value of type double to type int. And maybe for this one, we realize that, well, you can't actually have 10.99 potatoes. Maybe you mean 11 potatoes. If you choose this fix, you are casting 10.99 into an integer, but casting a double to an integer pretty much just means chopping off whatever was after the dot. So that's not quite what we want. So I'm just going to, well, let's just change this to 11, shall we? That's my fix. And I'm going to take a screenshot of my answers and send them over to the Padlet. To take a screenshot, the keyboard shortcut is Command-Shift-4. And you just need to drag from the top left-hand corner to the bottom right-hand corner. Take a screenshot, head over to the website. We gave you the link just now. And you can just drag this little thing into the Padlet. And once you let go, it's going to upload and your answer will be right there. Next up, we're going to talk about operators in Swift. For this section, let's go create another page, and let's call it operators. Operators, right click, rename. And that's a good chance for me to show you how to rename these playground pages. So over here, this is not so much learning Swift, but it was more of variables, constants, and types. Okay, so to change it, you just need to two-finger tap or right-click if you have a mouse and choose rename. Let's go enter some code here. We have all these variables and constants, and what do we do with them? We can treat Swift Playgrounds like a really large calculator. And we're going to just create some constants. Let sum equals to 1 plus 1. And if we press run, we are going to see that there's a little 1, 2, 3 over here. Let's click on it. And it says 2. So that's a little insight into what's going on in the brains of the computer. I'm going to click on add viewer so that we always know that what that is. Let's go create something else. Let's let difference equals to 5 minus 2 perhaps. And if I click run again, okay, that's simple enough. And we can also make results that depend on other constants and variables. So let's say diff minus sum. What's going to happen? It's going to take the result of this, which is 3, subtract away 2. This is all just manipulating things, kind of like algebra, not something that's awfully difficult or different from anything you might be used to. Now let's try out multiplication and division. And you'll notice that I've been using let, right? You can also use vars as well. The reason why I'm using let is because I know that I'm not going to change any of these numbers afterwards. So I'm going to say let a equals to 10, let b equals to 20. I don't actually need to see viewers for these two because I kind of know what they are. If I want to do a product, I can say product equals to a times b. B over a equals to b slash a. And let a over b equals to a slash b. See how I name these variables? I cannot have spaces in them. So I'm going to just type b capital O and, oh, that's right, that's a lowercase v, over and capital A, just so that it's we are kind of able to distinguish between the different words in a variable name. So let's click run my code to let it process all these. I'm going to see what product is. That's 200, not surprising. I'm going to see what b over a is. What's 20 over 10? Yes, that's 2. And what's a over b? What's a over b? Of course, 10 divided by 20 is 8. 10 divided by 20 is apparently 0, right? So has Swift failed basic mathematics? Not really. That's mainly because of the type system in Swift. A is an integer, b is an integer, therefore a over b is an integer. What's an integer representation of 10 divided by 20? Well, that's just 0, right? Remember 0.5 with the 0.5 chopped off is 0. So if you really want this to be a decimal number, you can put a over b. Hey, this thing's a double right here. I want to take a and divide it by b. Now, the problem here is that that's an error. A over b is actually an integer. So the result of what you get when you divide a and b is an integer. If you really want to have each of these be able to divide by the other and give you some kind of decimal point, you have to convert this to a double temporarily. We're casting it to a double. And you're going to cast this into a double as well. And now you don't need this. You don't need this type annotation anymore because that's given, when you take a double divided by a double, you should get a double back. Let's run the code real quick. And now this thing is become 0.5. Let's work out the order of operations. If you have something like this, let order equals to 5 plus 2 times 3. It's going to do 2 times 3 first and add 5. That's your mathematical order of operations, and Swift just follows that. However, if you do parentheses, it's going to take 5 plus 2 first and then multiply by 3, and that is going to give you, as expected, 21. This shouldn't be too surprising. There are a few other operators around, but we won't go into all of them. One useful one and interesting one is a remainder. So what's the remainder of 21 divided by 5? So the remainder of 21 divided by 5 is 1. Right? So I guess if you ever wanted to divide some cakes, right? So let cakes equals to 190, and there are maybe 21 people. How many cakes does each person get? Cakes per person equals to cakes divided by people. And this is a point where integer division actually comes in handy, right? And you can have leftover cakes equals to cakes modulo people. This percent sign is called modulo. Let's take a look at the answers. 190 cakes, 21 people equals to 9 cakes per person. That is fantastic. I always love having 9 cakes. There's only 1 cake left over, which is not bad. Let's do an exercise on operators. Click on the left-hand side and press plus, and you can type in exercise 2 operators. And let's type in some code. So let's say we're taking care of an inventory of MacBooks and iPads. So we could have a variable to track the number of MacBooks that we have. This is definitely a var because we're going to change it. And we could have another variable that tracks the number of iPads that we have. Notice how I named these variables num MacBooks, lowercase n. Variables always start with lowercase letters. You don't have to, but it's convention. And subsequent words, you capitalize each letter. This is called camel case. It's like a camel with the head down and the hump up. I didn't do it for iPads because it just looks weird to have capital I's over here. So we're loaning out some MacBooks and someone has borrowed a MacBook. How do we account for it? We subtract 1 from the number of MacBooks. We do that by saying num MacBooks equals to num MacBooks minus 1, which is something that you wouldn't want to tell your mathematics teacher because this equation makes no sense. Num MacBooks can technically never be equals to num MacBooks minus 1 because then minus 1 is equals to 0 and everything is equals to everything else and the world is burning. But in Swift and many other languages, the equal sign does not mean equality. It means assignment. You're taking whatever's on the right-hand side and putting it into the luggage or the box or the variable that is on the left-hand side. So this is 10, subtract 1 from it, and it becomes 9. So num MacBooks becomes 9 after this line. Let's run it real quick to prove that we're correct. And we will click on this right here, and there you go. Num MacBooks is 9. Let's add a viewer. Let's say we also get a donation of iPads. All right, we could always do with a donation of iPads. You could do num iPads equals, you could do num iPads equals num iPads times 2. But I want to introduce you to a new operator that's just like this. Num iPads times equals to 2. And that means whatever it used to be, now it's multiplied by this much. And of course, there are other equivalent operators as well for plus, minus, times, and divide. This should be fairly familiar to people from most programming languages. One thing that I should mention is that there is no plus plus operator in Swift. If anyone is coming from a language that there is a plus plus. So what's our total number of equipment now? So equals to num MacBooks plus num iPads. And if I run my code, it shouldn't be surprising to you to know that this number will become 29. 29. 29? 29. Yay. Okay, so at this point, I'd like you to help me out with a couple of operations. And to do that, I'm going to type in a comment. I've written this once just now without explanation, but I think you kind of get the idea. When you type // you're going to type in code that is not being interpreted by Swift. So we can type in anything you want, and this is meant to be read by humans. So in this case, we are going to say, what if someone eats an iPad? Remember, there are hungry people about. Now let's also recalculate the total. So just 2 lines of code. This line here, you're going to calculate the new number of iPads after one has been eaten. And you could use something that looks like this operator, perhaps. And after that, you're going to need to recalculate the total. So what if someone eats an iPad? We could just follow this line over here, where we say num MacBooks equals num MacBooks minus 1. Or we can say num iPads minus equals 1. Let's take the current value and subtract 1 from it. You could subtract 2, you could subtract 3, but in this case, we only want to subtract 1. Now, let's run it real quick, just to check to see if we got the right answer. And that's 19. We used to have 20, and it's now 19. The total, on the other hand, let's just type the word total and run your code and see whether we can get a total. The total actually remains at 29 over here. Let's go add some viewers for all these little things. So even though the number of iPads has reduced by 1, and even though the total is the number of MacBooks plus the number of iPads, for some reason, total is still 29. And that's because this line right here doesn't actually link to the number of MacBooks and number of iPads forever. It just takes the value at that moment in time, and that's 20 right now and 9, and it becomes 29. So if this number decreases afterwards, total is still stuck at 29. It's not linked to the previous value. If you want the new total, you're going to have to recalculate it by typing total equals to num MacBooks plus num iPads again. And if we run this one more time, there you go. Now it's 28 because it's taking 19 plus 9. I hope that kind of makes sense. And we'll add this to the Padlet and move on. This code is a bit long to try and add to the Padlet. You could reduce the font size, but these boxes are really large. You could remove the boxes before you copy and paste it over. But what I'm going to do now is, instead of copying and pasting a picture of it, I'm going to paste it into a haste bin. So I'm going to copy all this, open up a new website called code.tk.sg, and just paste my code and press this save button, this very outdated save button. You're going to generate a new link up here, press copy, and just over here, create a new post and type in exercise 2, and just paste in the answers over here. Back in Swift Playgrounds, let's go make a new page. Press plus over here and printing. Not the type where you have toner and ink cartridges, but printing to the console. And what's a console, you might ask? Let's try it out. So we're going to do this thing over here. We're going to say print hello world. If you've ever done any programming tutorial, that's the first thing they ask you to do. We, on the other hand, took over an hour to get to this point, but we're finally here. Click on run my code, and this thing should light up. And if you click on it, you're going to see hello world over here. This thing over here is the console. It's a bit of a hidden system area for programmers. This is not visible to any of your app users, but it's something where you can just put some information for yourself, or iOS might be sending information to you in the console. One thing we want to do when we enable the console is to turn off results. And the results are those little previews that we had previously. And we don't need those anymore. It was a bit of a trouble trying to get them to even work in the first place, and clicking on them was a pain. So let's turn it off, and we will rely on the console to print things out for us. So what else can we print? Remember when we did some math, we can say var a equals to 10, var b equals to 5200. I could print a times b. I could take whatever's inside and just print it out. Let's press run my code, and here you go. Okay, I can do this with integers, I can do this with strings, and I can do this with doubles. 10.99, 5200.5, press run, and fantastic. I never need to know this sum ever. We can also manipulate strings and numbers to mix them together when we print them out. Let's see how that works. Let's say we have two favorite snacks. Var snack 1 equals to Nutella. Var snack 2 equals to Cadbury. And I'm going to say print. I could just print snack 1 and print snack 2 separately, but that wouldn't be very exciting, right? That's kind of like just printing hello world. What if I wanted to express my appreciation for these two snacks? I'm going to say my favorite snacks are, and I'm just going to close my string first, and I'm going to type this strange little thing, a backslash and open and close parentheses, and I'm going to put snack 1 inside. Okay, so just follow along if you're doing this. And I'm going to put snack 2 inside here. Let's try this real quick. What happens is that this little thing over here takes the value of this variable and puts it inside here. It takes the value of snack 2 and puts it inside there. That's called string interpolation. It's just a fancy way of saying substitute this thing for what its value represents. And you can do this with numbers as well. So var num snack 1 equals to 25 and var num snack 2 equals to 900. And I can say print I have eaten num snack 1 and num snack 2 snack 2s today. I should see a doctor. Let's run this and see what happens. What happens is I have stated that I should probably go see a doctor because I've eaten 25 Nutellas and 900 Cadburys today. But more importantly, I've taken this number over here, 25, and interpolated it into this string. And I've taken this string over here and put it inside here, and 900, put this inside here, and snack 2 and put it inside here. With that, let's do a quick exercise on printing. So exercise 3, printing. And for this one, I don't have a lot of code for you. I just kind of need you to print 3 things after defining 3 variables. So variable 1 will be your name. So set your name to be something. Variable 2 will be your favorite snack. And variable 3 is how many times you eat snack. And there's got to be a number. And I'd just like you to print out 3 things, which is, hello, my name is, and my favorite snack is, oops, I eat it how many times a day. And of course, print out the full sentence, and whatever you print out has to depend on what you type inside here. Let's go. Here we go. So let's fill in your name. That's me. Favorite snack. You know this, Nutella. How many times you eat snack? That's maybe 49. That sounds about right. And inside here, you got to print, hello, my name is, and remember to close it first if you want to be able to autocomplete. And now you can type name. You can also type from start to end. It's just that the autocomplete doesn't work very well. So my favorite snack is, and now there's no autocomplete. Okay, and also you get this thing where it thinks you want to start another double quote. You want to start another string. And finally, I eat it. How many times? How many times you eat snack? And this is an example of a little bit of an extreme variable name. You probably don't need something so long, but it is very descriptive. You kind of know exactly what the variable name means just by looking at it. And we're done. Let's save this, run it, and just check to make sure that it works. And also open up the console, and you're going to see it right here. I eat Nutella 49 times a day. Let's go add this code to Padlet, and this is easy enough for us to just move over with a screenshot. So Command Shift 4, will let us take a screenshot, head over to the Padlet, that's right here, and drag it in. And if you can just label it exercise 3, that would be fantastic. It's time to head back to Swift Playgrounds, where we'll use what we learned to build a simple app. What we'll be building is something that will help me keep track of how many jars of Nutella I've eaten through a day, which is very important to me. Let's click over here. This is a placeholder, and I'd like you to type in text. You have eaten 0 jars of Nutella today. That's a bit like a print statement, right? And you're just saying you print this string to the screen. Now we know this is called a string. So click on run my code, and it's gonna tell me on the screen, you have eaten 0 jars of Nutella today. I'm going to do some simple modifiers to make the font size a bit bigger. If we did font dot system size 36, and you can always press Command R to run. And let's make this bold and give it some padding. All these are things we went through in the previous lesson. And what we want is we want a button that, when tapped, will increase the number of jars eaten today. So we're going to press enter. And you know that if you're going to add something underneath this, you have to actually put this text inside a VStack. So let's do that. So let's type VStack. And if you remember the little shortcut, you can drag this curly brace so that the text ends up in the VStack. And we're going to do button. And the way the button works is you give it a string to display. So another one, please, exclamation mark. And afterwards, you need to give it an action. An action in curly braces is a number of lines of code to run. We'll leave this alone for now and press run my code to make sure that it still works. And here's our button. Let's style our button real quick by giving it a font size. Let's give it a background color. Color.blue. And give it a foreground color of white. Bit of padding. And remember, we should put the padding before we apply the background color. And maybe some corner radius to round off the edges. Let's run it and see what it looks like. Okay, that looks like a nice little button to me. From here, we now need to introduce a way to keep track of the number of jars of Nutella eaten. And we want to increase this number when we press the button. First things first, let's add a print statement inside here. So print, yay, because that's what you should say when you have another jar of Nutella. So press this button. Notice that the console lights up over here. And every time you press this button, it says yay. Alright, so that's the print statement. It prints to the console over here. So you can hide the console, and we can now add a variable to keep track of the number of jars of Nutella we've eaten. So up here, I'm going to add a variable, and this variable is going to look a little different from what you saw in Swift. So you have to type the word state var numJars equals to 0. You have to include this or it won't work. We'll explain more about this when we reach Xcode. But for now, what I'd like you to do is to bring this number into this string somehow, so it's no longer stuck at 0, and add one line of code so that when the button is pressed, the number of jars is incremented. Now we're going to get this variable into this string. And how we do that is by deleting away this 0. That's a hard-coded 0. And instead, we want to bring in the string interpolation of numJars. So now, if numJars happens to be 10, and if you press run my code, you're going to see you have eaten 10 jars of Nutella today. Not inaccurate. But let's set it back to 0 first, so we can start counting from 0. The other thing I asked you to do was to increment num jars by 1 every time someone presses another 1, please. And that's not difficult. I'm just going to say num jars plus equals 1. And you see that I got rid of the print, and that's because the print was just a placeholder for me to check whether my button was working. You don't always need these placeholders, but they're nice to have when you are coding, just to see if the button is really responding. Let's test out our code, and you can click on this button. Every time you click on this button, it's going to increase the number over here, num jars. And when it increases, it's going to, well, it increases using this line, it's going to put this new number inside this text. And the special thing about SwiftUI is when you have a state variable that's embedded inside a text on the screen or any kind of view on the screen, a change to the state variable is going to make the visual element that contains it refresh itself. Don't worry if that didn't really make much sense. We'll do a lot more of this. But this is the first time you're doing SwiftUI with some changing piece of text on the screen. The last thing we did was a name card, and that was completely static. Now you have something that actually changes on the screen. So my challenge for you now is, can you make a button that reduces this by 1 and another button that resets the num jars variable to 0? Let's add the second button that reduces the number of jars of Nutella. Let's do it this way. So button, 1 fewer now. I feel obliged to give a sad face. Open curly brace. And you can probably guess what goes inside here. Instead of adding 1, you do -1. Let's run your code. At this point, you realize that it's a bit smaller text, and you might want to copy this over and maybe change this to red. So it's a slightly different color, or orange. Orange. Right, we're going to save red for when you reset your code. So 1 fewer now. Oh, let's go negative. Maybe we'll fix that next time. And finally, we want one for a reset button. So here's one last one for a reset. So button, reset to 0. And here we're just going to set num jars equals 0. So for this, I'm going to copy over all these modifiers and change the color to red. Let's run the code. And here you go. Increase, decrease, and reset. Increase, decrease, reset again. And I'm sure you can come up with other ideas about what you can use this for. Maybe you want an app that counts the number of laps you've run. Maybe you want an app that counts the number of times I've been rickrolled while making these tutorials. I'm sure there's something you can make with your own ideas, and I'd like you to think about that. I have one last thing for you to think about, and that's got to do with these numbers right here. You'll notice that every button is of font size 24 and has a corner radius of 10. And it's good that all the buttons are consistent. Well, it's also because we were lazy and we copied and pasted the modifiers, but we can pretend that we were just being consistent. The problem comes when we want to change things. What if I want to change the button font size to 32? I'm going to change the first one, I'm going to change the second one, and I'm going to forget to change the third one, and it will look weird. If I notice it before I ship my app, that's fantastic. But in many cases, we're going to forget and we'll have something strange going on. So you generally want to try and tie all these sizes together instead of having numbers floating around your code. The way we do that is by having constants. So we're going to say let button font size equals to 32. We're going to go down here and we're going to say, instead of size 32, we're going to say size button font size. However, this gives me an error, and instead of moving on to fixing the rest of them to button font size, I'm going to fix my error first and see what Swift has to tell me. So I tap on this, it says, cannot convert value of type int to expected argument type cgfloat. I think you kind of saw this when we did variables, constants, and types, except you didn't come across something called cgfloat. A cgfloat is a floating point number, and that's what the size over here seems to be expecting. And let's just try pressing fix. This should look familiar. This function over here is taking a button font size as an integer and casting it to a cgfloat. That's one way to solve this problem. Another way to solve this problem is by using a type annotation. So instead of letting button font size be 32 and defaulting to an integer, I'm just going to say, hey, this thing right here is a cgfloat. Now replace all our size 32s with button font size, and down here, button font size. And if I run my code, everything is consistent. And the great thing is now I can just change one number up here if I want my font size for my button to be nonsensically large, like 72. I can do that with one change without having to worry about editing 3 different buttons. See if you can spot any other numbers that we can convert to constants that you can put at the top of your code. You will see all these things in one place, and it's a lot easier for someone else looking at your code to modify your code without having to dig through all the things that you've written. Oh, we're back. Hi. So thanks for joining us today. We learned a bit about Swift, the programming language, some programming fundamentals, and we applied those to make a simple little counter app. And we're going to build up this counter app to make something more interesting, kind of like the demo that my colleague did up with the flag, because it's the same concept. You increment the number and you make some changes to the screen. We're just going to have to learn a couple more concepts before we get any further with it. And before you know it, we're going to be installing Xcode, and we're going to be making much more involved apps as the weeks go on. So I'm looking forward to that, and join us for the next lesson. Thanks so much, and do take care. Bye.